a bridge is meant to get from this side to that side, but how can this experience enhance people's day? I really want to bring more to it than just pure function, but the function is at the core of often what the piece is about. So what else can I bring to the experience? Placemaking, the experience of that user. If they're just walking through the park, this piece is just there. Does it cause them to pause? Does it cause them to go over and touch it? Does it help be in the background of their selfie? You're always thinking about those kinds of things, and you hope that you're contributing more to the urban landscape than just pure object.
Welcome to the Community Center from Eryngo Urbanism, a show about bringing people together in places worth appreciating. I'm Kyler. I'll be your host for today. I'm an architect and design communicator based out of Oklahoma City. Today, I'm joined by a very special guest who will be helping us answer the question, how do we create a world where more people get a chance to engage and interact with art in their everyday life? Stan Carroll, welcome to the show. Could you start us out by telling us a bit about who you are and what you do?
Well, Kyler, thanks for having me. I really appreciate you letting me be on and participate in this terrific effort that you've been putting on for quite some time. I guess, in a nutshell, I was an architect for a couple of decades, and then after about 20 years or so, really a little earlier than that, I started kind of dabbling in public art and building furniture and very creative art furniture stuff. And so I really love the making part of things. And it really became apparent that doing architecture is terrific. I love it. Nothing I love more of great education basis. But I really was drawn to the artistic side and more of the making side. And so about 20 years ago, I transitioned my practice to purely doing public art and other types of artwork, mostly sculpture, abstract sculpture, and have made the transition. I haven't done a building in probably 15 years or so, and just don't even look back. I just kind of keep plowing forward in the art world. And it's surprising how my process is very architecturally based. I mean, if you were to sit down and work with me any day of the week, it would feel like a very natural architectural process. So I haven't abandoned architecture at all. I'm just kind of changed the things I create, from buildings to sculpture and public art.
Yeah, so to elaborate on that, in what ways would you say that your background in architecture has shaped your approach to an art project?
Yeah, in the public art world and, functional art like furniture and things like that, it's still very much the same questions we're asking. We're asking about context. We're asking about function, if it's a functional piece. We're asking about how humans interact, how they engage each other in the space. It's about space making, place making. It's all just almost the exact same thing. It's just I'm expressing it in a slightly different way. In a nutshell, that's pretty much it.
Yeah. Yeah, so on some of your larger projects like the Skydance Bridge and Doris Miller Memorial, you are a part of a larger team that's working on, the surroundings, the landscape, et cetera. So how have your experiences been working in those types of environments, and what's your role on that larger team like?
Right. It ends up being very close collaboration. I love collaboration. It's like my favorite way to work, although I enjoy working by myself as well. But the way they typically work, and the Skydance Bridge was quite some time ago. I think we've designed it in 2008 and it got built by 2012. I think it was completed. So that's been, 14 years, I guess, ago. And that was really the first big major project with anything very complex. And that was a huge team of people. Hans Bootzer was one of the co-designers. There's this whole group of people, Ken Fitzsimmons, Chris Ramsayer, a lot of folks. I'm missing names here. But anyway, and then there's the contractors. That was Manhattan Road and Bridge. They did a terrific job. Swanda Brothers were the fabricators who actually fabricated kind of the complex parts. So there's always a huge conglomerate of people on the larger projects. That was $6.5 million project that took us a couple of years to design and a couple of years to build. As far as my role on that, I was really responsible for the geometry. I was managing that geometry through many schemes. We did many schemes, and we ended up having to redesign it. We designed it twice. We redesigned it once because we were under the budget that they had set forth, and we were up at like $16 million. City was on board with that estimate and everything. And then the 2008 economic turn down hit, and the mayor came to us and they said, guys, we know you're on budget. We've agreed this whole time that you were fine on budget, but the economic downturn just hit, and we cannot look the public in the eye, even though we were planning on spending $16 million. He said, we cannot look the public in the eye after an economic downturn like this and go build a $16 million pedestrian bridge. It's like, oh my gosh. So we basically said, well, what do you think the budget needs to be? And he said, well, we think it needs to be 6.5 million. And so we kind of, a big giant lump in our throat, because you can always cut 10-15% out of a project usually, unless you've already really tightened it up, but to cut 60% out of a project is almost unheard of. And so what's fascinating is to see the project that was the $16 million version and then see what's there today now. And I swear to God, I believe what's there now is better than the $16 million version that we did. It's kind of the dynamics of constraints and really having to bust in and really carve out the things that are extraneous or extra and just include the things that are critical and primary to the whole idea. And dramatic difference, very dramatic. The original idea was all very flat plate, big start, big surfaces. And then the newer version, as you can see, there are truss versions. And then we added the feathers on the outside that really added visual weight. We didn't want just these trusses sticking in the air because that felt just like oil rigs or something. And that felt a little too kitschy for Oklahoma. And so we needed to add some visual weight to those surfaces. So that was where I kind of developed a lot of the algorithmic stuff with Grasshopper, was on to developing those feathers. There were like 700 feathers, 10,000 bolts, and each part unique. Each bolt hole pattern was unique to that specific part. You originally asked what my role was. Well, it was to manage most of the geometry. On the Doris Miller Memorial, that was a lot smaller team. It was only about a $2.5 million project. And really, I developed all that geometry. I was really working fairly solo. And then I had a structural engineer, James Hoffman, and there was a mechanical engineer and an electrical engineer. The mechanical engineer there was pools, and he did all the water treatment stuff. And then the electrical, of course, did the lighting and stuff. But that was a much, much smaller team. That one has like 1,500 parts, and it's all algorithmic, not just the feathers. But that piece, if you go online to my website and check that out, beautiful piece. There's no internal structure to that. All of the stiffness, this is a 17-foot tall wall that has to withstand 110 mile an hour winds or whatever it was. And all that performance was generated through just the stiffness of the arrangement of the panels. That was really, that was a result of systemic design, where you design a system or an arrangement of a material system. And then that system generates stiffness in a very kind of complex way. But that one was probably the one that I'm most proud of, because that was done much more recently. As you hope your more recent work gets better and better and better. After I designed the Skydance Bridge, I went and did a master's degree in London at the age of 52. I wasn't quite this gray-headed then, but everybody in the class was basically half my age. It was this incredible, incredible school called the Architectural Association. I don't know if you've heard of it, but Zaha Hadid went to school there. Rem Koolhaas taught there. Patrick Schumacher of Zaha Hadid teaches there still. Incredible alumni from that school. And they're just super into this algorithmic, they just come at problem solving in a much different way. And so that was very, very eye-opening. Maybe the best decision I ever made in my career was to go take a year and go do a master's degree, because I had already discovered algorithmic work, but I knew there was incredible potential, but I couldn't tap it. It was so mind-blowing that I couldn't figure out how to tap it myself, although I was doing kind of some fun stuff. But then once I went there, I kind of got in the culture. Everybody there is doing that kind of work. There's something to be said about immersing yourself in a culture of the type of thinking you aspire to do. And so that was an incredible experience. And that's where I really leveled up my algorithmic game during that master's degree. So
that's awesome. One thing that I think is kind of cool is that you like to use a lot of algorithmic modeling and manufacturing processes. And so how does that assist you in creating something unique? And what are some of the intricacies with that process?
Yeah, great question. I love that. One of the favorite things I love to talk about is computational methods. And I started doing that about, I'm going to say, I started using Rhino back in the early 2000s, maybe 2003. And then about 2009, I found Grasshopper, which was an algorithmic process within Rhino that a lot of people might be familiar with. And so that really fascinated me. And what I found was computational methods allow me to search a larger solution space. And so instead of being limited to building objects and drawing objects, now the algorithmic process, I think more in terms of building rules and building these rules that then the algorithm kind of follows those rules and often generates things that I never expected, or sometimes maybe I did expect or whatever. But that's the fun part about it, is you write these rules that develop relationships, geometric relationships, structural relationships, functional relationships, any kinds of relationships and rules. And by using those rules or applying those rules algorithmically, or just with the computer, crunching through the numbers and things, it often reveals these amazing solutions. If you write the algorithm correctly, it can be really super smart solutions, because the rules you can make is, okay, develop this geometry that might randomly search out in the solution space, but always keep it structurally coherent. And so it's kind of a beautiful way to constrain things without having to really crunch through all the numbers myself. You kind of employ the computer to help assist basically enacting those rules. And so it's really, really energizing when you find some solution that you really had no intention of creating, but because you built that algorithm and sent that algorithm off to kind of seek out into that search space, it reveals things that no one would have ever thought about had they not kind of applied or set out to see where those particular rules might lead you. So,
yeah, I personally really love Grasshopper. So that's partially my personal reason for asking about that. But is it challenging when you have these really complex algorithmic forms to explain to somebody how to put those things together? How do you?
well, a little bit. And I do adopt a lot of that work myself. I mean, because this process often yields complex geometry, and a fabricator's draft person that he has in his office that he builds stuff every day, he can't really do that because he doesn't understand the way we got there. And so it turns out that the only way this kind of work can actually happen is that I have to employ my algorithm to generate the geometry itself. So often, most of the time, dare I say all the time, I don't like using the word all, but most all the time, I generate the geometry myself and then hand that geometry to the fabricators. And then they basically use that very specific, precise geometry that was generated through the algorithmic process. And then they go cut it out or whatever, bend it up, and then assemble it. So that becomes part of my design process, is to track through not just the design and what this thing's supposed to look like or whatever, but it's also what drawings do you need to fabricate this thing? And these are not just these types of drawings. It's this specific drawing. You have to have this specific drawing to build this specific part. So what that ends up doing is allowing this beautiful opportunity to use variation. And instead of having to systematize everything, you can have grand variations. Often, a lot of my sculptures and work involve hundreds or thousands of pieces or parts. And most of the time, every part is absolutely unique. And it has a very specific position and connection to make with the adjacent parts. And you really just can't do that unless somebody is managing that geometry. And in the end, it's my responsibility, and I happen to use the algorithms to help kind of manage that work. So super fascinating that if you build the algorithm correctly, and that's a big if you build the algorithm correctly, the computer's very obedient, and it will, generate those parts exactly as you intend them to be. And so, knock on wood, I've been lucky that those have worked out. It's always kind of scary. You hand a fabricator enough drawings to cut up 50 sheets of stainless steel, and you're just crossing your fingers, hoping you did it right. And I guess when I finally fail in that, well, that was my last project. I'm not doing that again. But because really, I end up taking all the liability really on that, because if I hand them a bad drawing, but effectively what I end up doing is handing those pieces and parts in a 3-dimensional version. And so you can zoom in to every little part that's in there. The fabricator can. He doesn't just cut these parts and say, oh, okay, I'll just trust it and just cut it. I'm giving him a very highly precise 3-dimensional model, accounting for material thicknesses, which is no small task to be able to account for that, and accounting for bend allowances. I don't know if you understand how sheet metal bends, it's not as simple as one might think initially. It's a much more complex consideration, and that's all part of the algorithm, is how to consider things like material thickness and bend deduction. It's called bend deduction, and you have to deduct certain dimensions in order to make this bend actually work and meet up after it's already bent. And that is no small task. That took me a long time to engage that aspect. Early on, I was really kind of just doing a lot of flat stuff. But once I started bending things and everything, it got really hairy. But then once you kind of master and figure it out, you're off and running. So anyway, yeah.
Yeah. I think one thing that's really interesting about your work is that the forms and the artwork itself is all very structurally expressive, and the connection details are all very important. You mentioned the number of fasteners on the Skydance Bridge. So why do you think structural expression is important, and how can more people learn to design in that way?
I love that question. I mean, that's a real mindset shift for a lot of people. A lot of people are thinking, shape and form first and structure second. You kind of come up with a design and then you take it to the engineer. That's kind of more traditionally how at least Americans designed. But this European version that I kind of learned integrates structure in with the initial thinking. In fact, one of my professors, there were 2 professors. One of them was an architect. The other one was a structural engineer. And so he was paramount in teaching us all how to consider structure in the essence of the piece. And so whenever you're developing these algorithmic systems, you're building these rules, and a lot of these rules are structural rules. And so the structure doesn't want to be after the fact. The structure wants to be integral with the initial decision-making process. So if you're off designing something that makes no structural sense at all, you shouldn't be anywhere near there. That structure should be integral with your entire thought process, just like mass and texture and color and volume. All those things are important aspects, but structures is right there with those. It's got to carry its own weight and contribute to the solution just as all the other aspects are. In fact, part of what we learned in that master's degree was how to do structural analysis, finite element analysis in the computer with RISA or whatever your favorite FEM software is. So that was part of what we did. We had to analyze it all. In fact, when I did the Doris Miller Memorial, that was after I'd done this master's degree, I did all the analysis myself, right? Now, I'm not a licensed engineer, nor can I stamp the drawings. But what I did was I worked through many solutions, including the structural analysis. And so when I did approach the structural engineer, I had a solution that I knew already worked, because I had already worked it out with the finite element analysis. And so when I handed it to him, I said, you've got to stamp this. You've got to satisfy yourself that this all is going to stand up. But I believe this already works. And I said, if you think it's not going to stand up, please tell me, because that's the last thing I want it to do. But I had already done all the analysis, and he kind of checked it off. He also contributed a lot more than just checking my work. Trust me, it's sounding more like I didn't even need him, but I did. Absolutely. He was a terrific collaborator. James Hoffman's a super smart guy, and so happy to have him on the team. But that's kind of a clear indication of how structure is so critical, and you've got to consider it early. In fact, it's driving decisions. For instance, when I was doing that finite element analysis, I had the thing set up, right? And I would apply some loads to it, the 110 mile an hour wind and the gravity and all the stuff. And you'd look at deflection, find out how much the wall is deflecting once you apply those loads. And when I first plugged in the first scheme, it was like moving 18 inches. I'm going, oh my God, that's going to kill somebody. I said, this does not work. I haven't even been to the structural engineer yet, But through the algorithmic process, and if you haven't seen the project, just know that it's a curved wall. It's double curved. It's basically half of a ship hull. You've probably seen it, but maybe some of the other viewers haven't seen it yet. But just so that they understand the discussion here, it's curved in plan and it's curved in section. So it's double curvature. It's 140 feet long. Up at the bow is 17 feet. It slopes down to the stern. It's about 5 feet tall at the back, but it's 140 feet long, this giant curved wall that's curving along the plaza. So just to give you a sense of this big double curved surface. And so the only reason I wanted everybody to see that, because I had that whole shape defined where I could completely manipulate the wall with 3 lines. There was a line that represented the top edge, a line that represented the bottom edge, and a line that represented kind of the belly or the middle line down the length of the ship. And so basically, and this is the beauty of algorithmic processes, is I could take that line and just grab a couple of control points on that line and manipulate, make it fatter or make it more curved or whatever, add more belly in the curve or whatever. And then I could immediately feed that into RISA. So in about 20 minutes, I could manipulate the shape and then put it into RISA and understand what the deflection was. So that first time, that deflection was like 18 inches. And I said, oh my God, I'm going to kill somebody. So I just started manipulating those 3 lines. There was a 4th line, and that was thickness. It kind of had to do with thickness. And so manipulating those 4 lines, and in about a half a day, I went through the process 5, 6 times, adding more belly, adding a wider foot at the base, and making the wall more curved or whatever. I changed it in all different ways and had varying degrees. By the time I was done, I had 1 inch of deflection. When I applied the load, it was 1 inch of deflection in half a day. Imagine if you had a structural engineer and every time you wanted to make a change, you had to send it back to him. He'd have to figure it out and do all the stuff. That back and forth would take 3 weeks, But in a half a day, I went from 18 inches of deflection to 1 inch of deflection. And then when I handed it to him and said, I think this works. I think I've got it down to 1 inch of deflection. You check it. Tell me what you think, whatever. And after he looked at it for a week and came back and said, Stan, I didn't get what you got. And I went, oh no, I blew it. I'm going to have to start all over. He said, I couldn't get it to do a single inch of deflection. All the deflection I could get was a half an inch. So it was sweet. It was like, wow, he completely, psyched me out because he knew I had worked so hard. So he loved razzing me a little bit. And the only reason he came up with a half an inch deflection and I had an inch deflection was because he could make much more liberal decisions. I kind of barely know what I'm doing, right? And so I'm taking the most conservative decision every time I can. He's got the smarts, the innate smarts to kind of take a little less conservative. And so that's how he was only getting a half an inch deflection. So we were off and running. And so we didn't have to do this huge back and forth. Oh, this doesn't work, Stan. We got to change the design, whatever. I had already done all that. See, so that's kind of a great testament of the way the algorithmic process offers up the ability to kind of, as a designer, to be a more complete thinker and not rely so much on the structural engineer. He's got to do his job and make sure the thing's not going to, but arriving with a solution that is in good shape already is a huge leap forward in saving him his effort. Otherwise, he'd have had to gone through the 10 versions to get there.
Right. You've talked about the Sagrada Familia in Barcelona as being a great example of art and architecture integrated together. And I think one thing that I know about that building is that the forms of that building come from the structure and what is required, and the whole design process there is fascinating. But that in Gothic architecture is the same thing, where it's this form-finding exercise to get to the final product. And it's interesting to see how that can be done in a completely different style and in a completely new way, thanks to the tools that we have. So I'm curious your thoughts on if there's any through lines to how we did architecture back then to how you're doing your form finding and that kind of thing.
I love that. There is such a direct line, I think. Gaudi, he did very sophisticated analysis of the hanging chain. I don't know if you're familiar with that, but hanging the chains that were basically a diagram so that all these chains now are in perfect tension. And so when you flip that over, now that becomes perfect compression. And that's what masonry wants to be, is perfect compression. Masonry does not take tension very well at all, nor bending. And so if you can put it in perfect compressions, but basically there's a model that's happening, and that's what he did. It happened to be in chains. He didn't have a computer that could do the numbers, but it's almost exactly the same thing. Brilliant. When I heard that story about the hanging chains, was mind blown on how brilliant that was. I mean, my gosh. And so, yeah, it's quite analogous. Now our tools, are a gazillion times more sophisticated. However, they're not really achieving anything more than that hanging chain model did. It feels like it's almost the exact same thing, only in obviously an analog version versus a digital version of today. And the digital can obviously take us much further and has the ability to kind of do that same stuff just on a completely different level.
Yeah. I think some people may think that there's a big difference. I mean, and obviously there is, between like the intricate stone carving and some sheet metal forms that are found in a different way. I guess the question that I'm getting at here is like, how would you define beauty and how do we achieve it?
Wow, that's an incredible question. I'm not sure I'm capable of answering it, but I'll sure give it a shot. I love a good challenge. How do you define beauty? Beauty is about coherence. Beauty in architecture is about coherence. It's about how structure and form and texture and color and all those things come into reality and develop this perfection or this beautiful balance between chaos, which is just a bunch of crap thrown in, and perfect order, which is everything so rigid and boring and uninteresting. But it's really a spectrum. And on that spectrum is a position where the aesthetics that you've achieved or the beauty that you've achieved for this particular piece. And I challenge that you could almost take any project and put it anywhere along that spectrum, somewhere between chaos and order. And at any point on that is a solution. And so it's the coherence of all those elements, all the structure and form and all those things come together. And so where there's nothing left to remove or nothing left to add, I'm not the first to say that. I'm kind of repeating what I've said, but it was a beautiful kind of description of a masterpiece is when there's nothing else you can add or nothing else you can take away and have it improve any. So that's not my idea. I wish I had it, but I do strive for it often and regularly. But yeah, it's really that coherence is where everything feels like it's, man, this is just exactly in the right spot. This is the exact right color. This is the exact right form. This structure is working perfectly, efficiently, and all those things. And I'm not a big decoration guy. I like honesty of material, and it becomes its own decoration. So the Sagrada Familia has a lot of decoration on it, and I don't oppose decoration. It's just not what I strive to do. But then at the other end of the spectrum, I don't try to achieve this ultra modern minimalist. That, for some reason, the way my brain works, I need kind of some noise and some interest or whatever. Although my schooling, back in the early 80s is when I went to architecture school, and that was very modernist. What's the least it can be? Absolute box, and those always felt so stark to me. And they can be done as beautifully. You can find beauty at that end of the spectrum as well. But that's just maybe not where my tastes are. I enjoy a little more decoration, although not decoration for decoration's sake, but decoration is in an expression of the essence of the piece, structural intricacy or a form that's doing maybe extra work, like maybe modifying light textures or, 1,000 other reasons to manipulate a very simple form. So that's beauty right there in a nutshell. Write the book. It's right there.
Another interesting thing is that a lot of your work that you've done is kind of functional art that people are meant to interact with in some way. So I'm curious, what impact do those projects have, and how do you see the act of design of everyday objects as a type of art?
Yeah, I think that almost every piece functions at least in some level. Even the most just abstract sculpture that's just sitting there is functioning in some way. The challenge I always try to challenge myself with is to develop, meaningfulness around how it functions. Like a bridge is meant to get from this side to that side, but how can this experience that you're experiencing while you're doing it, how can this experience enhance people's day? What can make it a better day for them? And so it's not about the function, although you have to do that. But I really want to bring more to it than just pure function. But the function is at the core of often what the piece is about. So what else can I bring to the experience? It's really kind of experience-based placemaking, the experience of that user. If they're just walking through the park, this piece is just there. Does it cause them to pause? Does it cause them to go over and touch it? Does it help be in the background of their selfie or whatever, whatever the case is? But you're always thinking about those kinds of things, and you hope that you're contributing more to the urban landscape than just pure object. So how can you do that in an interesting way, maybe that hasn't been done before, or that might aspire to achieve something beyond what the initial requirement of the project was?
Yeah. So you mentioned creating the Skydance Bridge with 40% of the budget you expected to have. So I think a lot of people might say, well, we can incorporate more of these artistic elements into this building or that building if we have the budget. But how do we convince people that it's worth thinking about projects in this way, even when there's not art level budget? Does that make sense?
Yeah, no, it absolutely does. That seems like the daily challenge, isn't it, in the real world of, oh my gosh, every project is stripped down to nothing. That seems like the case. But it really comes down to the designer that's analyzing the actual needs of a project versus the assumed needs of the project. Rand Elliott is a good friend of mine. I respect the heck out of him. He's way off into that Stark world, super clean modernist. He does such a beautiful job of breaking things down into what's the least it can be. If I've heard him ask that question once, I've heard him ask it 100 times. What is the least it can be? And he will blow your mind because you're going, well, God, we've already stripped it down. There's nothing left. There's nothing left, Rand. We got to move forward. And he's genius in the way he ultimately lands in the essence of the problem. But he is serving the client in that he's trying to do the project for what they ask him to do the project for. And I always commend him for aspiring to actually do that. A lot of people just say, guys, we can't do it. We just need more money, and kind of give up. But you will get the very best project you can for the budget, whatever it is. So anyway, just shout out to Rand, one of my favorite guys here in town. So.
Not sponsored.
Yeah, right. Maybe he will now.
Maybe he paid you. I don't know. You didn't pay me. So I guess the last question that I have is what should be the takeaway in terms of how can we as a community advocate for more beautiful spaces, more artwork, that kind of thing? What can we do to support that?
Yeah, isn't that the proverbial question? Yeah,
I'm asking a lot of hard-hitting questions in this.
That is a tough question. As architects, you get up every day and you just try to do the best work you possibly can. I know that sounds a little idealistic, but that in essence is what you end up having to do. And hopefully you get better and better and you remain open to new ways of thinking. I think that's a big one. My trip to London just changed my thinking exponentially. So incredibly. And I'm so grateful for it. And it really has opened up new horizons. So it's really that being open and willing to rethink problems and tackle them from a new perspective, maybe that you've never tried before, or getting new players, new strategic partners, or whatever to tackle projects with. But trying to rethink and retackle each problem uniquely and break it down in the essence of the project, just like Rand does. He just breaks it down in the essence. And so, cha-ching, another set if I throw that
I'm
in.
going to need to get a cut of that.
But no, I think that's the biggest thing, is to allow your thinking to advance. There's a lot of guys I know that, man, they're just jumping through the same hoops they've always jumped through. It's like, no, dude, you got to move on. You got to try something new. You got to maybe fail a time or two so that you get better the time after that. So it's be willing to risk, and there's always a way to kind of salvage it if for some reason you make a bad decision. But odds are, if you think hard and long about something, it's going to be a better decision in the end. So, be willing to stretch out. So
if somebody wants to learn more about your work, where should they go?
Yeah, well, thanks for that. My website is beyondmetal.com, and I'm here in Oklahoma City and have a studio on 38th Street, and just give me a call or whatever. I'd love to talk with anybody about any projects they have going. Love to collaborate. I'm really trying to engage architects to consider how these algorithmic methods and complex geometries can engage architectural elements in feature walls, furniture, fixtures, whatever the case is, very custom things. I love a challenge. I love unique challenges. I'm completely bored if I have to build the same thing twice. And so everything I have is one-off. I continue to work smaller because I'm getting older. I continue to work large, but I'm also trying to engage the small world as well. My current kind of line of thinking is the fancy box. So something as basic and elemental as a box, I'm exploring how to do the most elegant, beautiful box. So I've got a lot of those going. So I can hit all scales. If you want just something for your dining table, that's okay. Or if we want to build a big piece for your backyard or whatever. So let me know. Thanks for having me. I really appreciate it. Yeah.
Yeah, thanks for coming, Stan. And I look forward to seeing what projects you get up to in the future.
Okay, sounds good. I appreciate your help. Thank you.
Hey, it's me, Kyler. If you enjoyed this conversation, please be sure to give the show a like, rating, subscription, or whatever kind of nice feedback you can provide on whatever platform you're watching or listening from. If you'd like to join our community to stay up to date or to discuss anything you heard in today's show, consider joining the Eryngo Urbanism Discord server. And finally, if you'd like to support the work of Eryngo Urbanism directly, you can do so over on Patreon. Until next time.